Okay, here's the solution for this FFT example problem. It starts out with, show me a proof of the decimation in time FFT butterfly equation. Okay, so let's go ahead and work through that just so that everybody's on the same page about that, because yes, I might ask for that on the exam. Okay, so the idea here is we start with the definition of the DFT. Okay, that's the sum from n equals 0 to n minus 1 x of n wn to the nk. All right, and we're going to break this up into two FFTs, and the way we do that is we sum from n equals 0 to n minus 1 of wn to the 2 n, wn to the nk. Excuse me. Plus, and we do n even, and then we sum from n equals 0 to n minus 1 x of n wn to the nk for n odd. All right, and then the next step is to take care of the even and the oddness by making a variable transformation. Okay, so what we want is n to be replaced with 2l, where l goes from 0 to n over 2 minus 1. Okay, so thinking about that, if you let l equal 0, n would be 0. If you let l equal 1, n would be 2. If you let l equal 2, n would be 4. So you see, by making this variable transformation, we are in fact picking up the even values of n. Okay, and then we just leave what's left. Okay, n again, instead of nk, this would be 2lk, and that finishes off the even side of that equation. Now let's do the same thing with the odds. All right, so in this case, we're going to still sum from L equal 0 to n over 2 minus 1, but this time we're going to do 2L plus 1. So n is 2L plus 1, okay? So again, when L is 0, n would be 2 times 0 plus 1 is 1. When L is 1, when L is 1, this would be 2 plus 1, which is 3. And so if you keep going like that, you see you pick up the odd values. Okay, so this would be Wn, and I replace the nk, the n part, with 2L plus 1 times k. All right, so we're getting pretty close. And what we do next is we just do some manipulations. All right, so this still is L going from 0 to n over 2 minus 1, x of 2L. These are just sample values, okay? And then I'm going to take this 2 and I'm going to move it down using properties of total factors. So I'm going to move that down to here. So Wn over 2, and so this would then just be Lk. All right, and I do the same thing over here for the odd values. So these are the odd samples right here, okay? And then this would be, okay, going to the side here, Wn 2L plus 1 times k is Wn 2Lk times Wnk. All right, so I'm going to factor this out, and I'm going to write what's left as n over 2 Lk. All right, so that's just justifying that arithmetic or that algebra. And so from here, what we notice is that we have the definition now of an FFT or a DFT, because these are the even samples, and then I multiply by this total factor n over 2 to the Lk. So I put on my pattern recognizer and I call that G of k, which is the DFT of, the n over 2 point DFT of the even values. Okay? And from there, I have this factor out here in the front, WNK, h of k, and this h of k would be the n over 2 point DFT of the odd values. All right, so that establishes the front half of the butterfly equation. Okay? So what we need next, oh, and by the way, k goes from 0 out to n over 2 minus 1. All right, so that picks up half of the k's. All right, so what we need next is to pick up the other half. And so what we can do is we can substitute for k. We can put in k equal k plus n over 2. So as k goes from 0 to n over 2, k plus n over 2 goes from n over 2 all the way out to n minus 1. All right, so that picks up the other half. All right, so this would be g. Everywhere I see a k up in this top equation, everywhere I see a k, I'm going to replace that with k plus n over 2. All right, so plus wn k plus n over 2 times h of k plus n over 2. Okay, so then we use the fact that the FFT, or the DFT, is periodic, with the period being the length of the FFT. Okay, so G and H are both n over 2 point FFTs, and so that means I can replace G of k plus n over 2 with simply just G of k, because it's periodic. Okay, and then in class we went through this, that this is just properties of exponentials, that this becomes Wn n over 2 times Wnk h of k. And then this term is minus 1. Okay, so that does it for the proof. This gives us both halves of this butterfly equation.